Hello, this is Yu from Electrical and Computer Engineering Department of University of Florida, and this is a presentation of wireless communications project. I choose the topic of performance analysis of OFDM simulator using MATLAB. And here we begin. And the first is the background of this project. In basic communication system, there exists a phenomenon named ISI. It's a form of distortion of a signal in which one symbol interferes with subsequent symbols. And if the available bandwidth of the data modulate is completely used by each symbol, the system can lead to ISI. And which means the previous symbols have similar effects as noise, thus making the communication less reliable. There are two causes of ISI. The first one is multipath propagation, and the second one is the band-limited channels. We need to find measures to eliminate ISI because we want our communication system more reliable. Actually, there are two methods for this. One is called equalization, and the second is what I will present today, the OFDM. Here's the introduction of OFDM. OFDM stands for orthogonal frequency division multiplexing. It's very similar to frequency division multiplexing, which is a FDM technology which has been widely applied in review stage. Like the basic principle of FDM, OFDM converts the high-speed data stream through the serial and parallel conversion, then assigned to a number of subchannels whose frequency is relatively low for transmission. The difference is OFDM technology makes better use of the control method to improve the spectral utilization. And how the OFDM counter ISI? It will use the cyclic prefix and the guard interval, which I will discuss later in the slides. OFDM has developed into a popular scheme for wideband digital communications nowadays, so yeah, it's good to research this. And OFDM has many applications, just like wireless local area networks, the LANs, and asymmetric digital subcarrier loop ADSL. And the final one is most common, the digital television. OFDM has many advantages and disadvantages. The advantages include its ability to cope with several channel conditions without complex equalization filters. And second, its high spectral efficiency compared to other schemas. Third is efficient implementation using fast Fourier transform. The last one, it can easily adapt to several channel conditions without complex time domain equalization. It has also many drawbacks, just like loss of efficiency caused by cyclic prefix and the guard interval. And second, it's very sensitive to frequency synchronization problems, and it requires linear transmitter circuitry, which suffers from poor power efficiency. Here is the OFDM simulator sketch I designed for this project, and I will discuss it in many parts. The first part, I will set parameters of this system. The number of subcarriers I set is 64, and the length of the IFFT and FFT is also 64. And I choose QPSK for the modulation scheme and set the number of OFDM symbol per frame to 2. In addition, the noise will be added by a WGN function in the MATLAB to check and evaluate this system by plotting the SNRBR curve. And the first part is the signal generate. In the signal part, I set the length is the number of subcarriers, which is 64, plus the NS and ML, which are both 2. So the length of the signal is 256, and we can see from this picture there are 256 plots in the picture, and the value of the bits are 1 or 0. And the second part is the serial and parallel conversion. Because the data generated by the transmission side is serial, we need the serial parallel conversion to make signal parallel. And then OFDM was able to distribute each row or column value to each subchannel, just like this picture. Just like this picture, the signal is already being distributed. And in my lab, I can use reshape function to make this conversion. The third part is the QPSK modulation. Because in MATLAB there are not such functions, so I designed one for this simulation. Why choose QPSK? There are many schemes of the signal modulation, just like amplitude shifting key and phases shifting key. In OFDM system, only the first 2 schemes can be applied because the subcarrier's frequency is orthogonal and carries independent information. And this is I describe the QPSK modulation, and I draw a constellation map of the QPSK modulation in this function. We can see 4 points, right here. And the next is the IFFT. From a system whose n is big, we can use discrete Fourier transform method to achieve OFDM. Therefore, the modulation and demodulation of OFDM system may use IDFT and DFT. But why I choose FFT and IFFT? Because it significantly reduces the complexity of the system. In MATLAB, I directly use the IFFT function to transform the signal, just like this. It's very easy because this function is already exists in MATLAB. Next part is the in the guard interval and cyclic prefix part. Since the duration of each symbol is long, it's feasible to insert a guard interval between the OFDM symbols, thus eliminates the ISI. That's how OFDM works. And when the multipass delay spread of the channel is less than the guard time interval, OFDM system can completely remove the effects of ISI. And in my lab, only 2 lines of codes can achieve this. Yeah, it's very simple. And after that, I will add noise by the function of AWGN already exists in MATLAB to make this signal more complex. Yeah, just like this picture. Yeah, the data really changed because of the noise. And next, I will remove the prefix and make FFT. Because before the QPSK demodulation of signal, I must remove the prefix to recover the signal with same length of the original data. After that, the FFT must be executed by MATLAB FFT function. Yeah, here is the 2 parts of the program. Last step is the QPSK demodulation. Just like QPSK modulation, I need first to create a function to execute this. And then, after we transform the signal in previous step to this function, we got the final signal received. There may be some wrong bits. Yeah, it's okay. That's how I calculate the BER. But in most part, they are same. Yeah. And finally, this is a BR curve I draw for the SNR. Oh, sorry, for different value of SNR. I plot the points by MATLAB, and I draw a approximate curve for this, and I compare it with the QPSK curve. We can see from this result, because before the SNR increased to 13, the pure QPSK system have relatively low BER and performance good. However, after the threshold of value 13, the QPSK with OFDM system beat the QPSK system with lower BER. Okay, thank you for watching. I will show the MATLAB codes I designed for this system. Yeah, here is the codes. Oh, actually, each part of the system I have already shown in the point. So what I need to do is just run this, and we can see from the result, and there are 6 pictures. Yeah, because I use the Randy function, so each time I run this, the data generated is not the same. Yeah, it's here. If I want to run this again, the data will change, and the BR also change. Yeah, it's equal to 0, so no bits so every bits is same with the original one. If I change the SNR value just like to 3, yeah, it's a little bit noise, so the BR increase. Yeah, we can see. And change to 1. Yeah. Okay. The error rate is much higher. Okay, that's the end of this presentation. Thank you.